Hello dear students, this is 10th class new maths textbook, the chapter number 1 real numbers. Here is the exercise 1.1 and this is part 3 video. In this video we will learn the solutions of question number 5, question number 6 and question number 7 of exercise 1.1. Dear students, this is the chapter real numbers and this is exercise 1.1. Here is the question number 5. Check whether 6 power n can end with the digit 0 for any natural number n. I shall repeat. Check whether 6 power n can end with the digit 0 for any natural number n. Here is the solution. 6 power n, here n is a natural number. Do you know what are natural numbers? Good, good. The natural numbers may start from 1, 1, 2, 3, 4 and so on. It is given that 6 power n is the given number and n is a natural number. Therefore, substitute n is equal to 1 first of all. 6 power 1 is 6. Next, substitute n is equal to 2. N is equal to 2 means 6 into 6. 6 6 are 36. Good. Next, 6 cube. 6 cube means 6 into 6 into 6. Already 6 square is 36. 36 6 are 216. Next, 6 power 4. 6 cube into 6, that is 216 into 6 is 1296. If you observe all these units places, all the units places are 6. Since 6 power 1 and with 6, 6 square and with 6, 6 cube and with 6, 6 power 4 and with 6, therefore all the expansions of 6 power n end with 6 only. For any natural number, so on and so on, so on and so on. Therefore, for any natural number n, 6 power n end with 6 only, but it doesn't end with 0. Clearly, for any 6 power n, all the values end with 6 only, but not with 0. Next is question number 6. Here is the chapter real numbers, exercise 1.1 and question number 6. Explain why 7 into 11 into 13 plus 13 is a composite number, and also explain why 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Here the sixth question contains two questions or 2 bits. First of all, you should prove that 7 into 11 into 13 plus 13 is a composite number, and in the second case you should prove that 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is also a composite number. In order to solve this, first of all, you should learn what is a composite number. Dear students, what is a composite number? Just recollect the knowledge of composite numbers. Good. When can you say that a number is composite? Okay. A number is said to be a composite number if it has more than 2 factors. More than 2 factors means the number of factors may be 3, maybe 4, maybe 5 and so on. So, for any number, if the number of factors is more than 2, such numbers are called composite numbers. How can you call a number with only 2 factors? Good. The number with only 2 factors is called a prime number. What is the least prime number? 2. And what is the least composite number? 4. Good. The least prime number is 2 and the least composite number is 4. And 1 is, please keep in mind, 1 has only 1 factor. If it has 2 factors, it is called prime number. If it has more than 2 factors, it is called composite. But since 1 has only 1 factor, 1 is neither prime nor composite. It is not a prime number, and at the same time it is not a composite number also. Good. Now you can observe this question. 7 into 11 into 13 plus 13. You can take this 13, you can find 13 in both, therefore take 13 common. If we take 13 common, it is in the form of 7 into 11 plus if we took 13 common, it is 13 into 1, therefore 1 is there. This is equal to 13 into 7 11 77 plus 1, this is 13 into 78. Already if you find the product and if you add 13, it is a big number and it has already 1 as a factor. The same number is a factor. It has 13 also a factor, it has 78 is also a factor, and 2 is a factor, and since so many factors are there, means it has more than 2 factors. Since it has more than 2 factors, clearly 7 into 11 into 13 plus 13 has more than 2 factors, so it is a composite number. Okay. Next, now let us prove that 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, it is also a composite number. In order to prove this, now the common number is 5, therefore take 5 as common. Previously 13 is common in both, therefore we took 13 common. And in this case we can find 5 is common, therefore took 5 as common. If we take 5 as common, then you have 7 into 6, this we took common, leave it. 4 into 3 into 2 into 1, plus we took 5 already common, but you can write 5 as 5 into 1, therefore 1 is there. Okay, is it clear? Good. This is equal to 5 into 7 into 6 into 4 into 3 into 2 into 1. If you multiply, you will get 1008 plus 1. 1008 plus 1 is 1009. Clearly, this product, the big number is a factor, 1 is a factor. Besides 1 and that number, 5 is a factor and 1009 is also a factor. Therefore, again, clearly it has more than 2 factors. It has more than 2 factors, so it is again a composite number. Good. Now let us solve question number 7 of the same exercise. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the same point? I shall repeat, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the same starting point? Here is a circular path. They are moving in this circular path. The first person is Sonia. Sonia takes 18 minutes to complete one rotation. Okay. Similarly, the second person Ravi takes 12 minutes to complete the same. Means Sonia may complete the first round in 18 minutes, second round in 36 minutes, third round in 54 minutes and so on. And whereas the Ravi takes the first round in 12 minutes, second round 24 minutes, third round 36 minutes and so on. Then in what time they meet at the same starting point again, it is the question. In order to find out, here you can observe, you have to consider the multiples of 18. First round 18 minutes, second round 36 minutes, third round 54, fourth round 72, means all are multiples of 18. Similarly for Ravi, first round 12 minutes, second round 24 minutes, third round after completion of third round time is 36 minutes. Those are the multiples of 12. Therefore, in order to find the answer for this, you have to find the least common multiple or LCM of both the numbers. Okay. Now let us write what is given. Time taken by Sonia for one round is equal to 18 minutes and the time taken by Ravi for one round is equal to 12 minutes. Now let us find the LCM. In order to find LCM, consider or divide 12 into prime factors, 2 into 2 into 3, and divide 18 into prime factors, it is 2 into 3 into 3. Now LCM is 2 square into 3 square. 2 square into 3 square is 36 minutes. Therefore, after 36 minutes, both may meet at the same point again, same starting point. Therefore, they meet again after 36 minutes. Is it clear? By this, we completed all the questions of exercise 1.1. Dear students, please practice the questions one by one again and again. If you find any difficulty, you may verify the video again. But still, if you have any doubts, you may please post your comment so that I shall explain clearly. Thank you. Thank you one and all.